By now we know how to graph with a y-intercept and a slope. We also know how to change equations around so they're in y-intercept form. So let's practice this. First thing you need to do is identify what is your slope. Here our slope is -1/2 and our y-intercept is 3. Slope is always a number with x and y-intercept is a number without x. So here that number is 3. That means I would go up 3 and put a dot. The reason why I'm going up is because my y-axis goes up and down, and 3 means go up 3. And now for our slope. Slope is -1, so we're going to rise by going down 1 and run by going to the right 2. So down 1, right 2. Put a point. Then do that again. Down 1 to the right 2, down 1 to the right 2. Once I run out of all my going down options, then I'm going to go back to the center point, which is at 3. And I'm going to go up 1, up 1, and to the left 2. Up 1 and to the left 2. Up 1 and to the left 2. Now, with these points, I'm going to connect my points. I'm going to put arrows because it doesn't tell me where to end it. And then I want to write my equation somewhere so they know what I graphed. I graphed y equals -1/2x plus 3. And that is perfect, full credit. I graphed my y-intercept, I graphed a few points using slope, I connected my points in a straight line, I put arrows, and I labeled. Perfect. So now today we are going to learn how to graph linear functions that are in slope-intercept form by using our calculator. So, just remember, let's first go over what are intercepts. Intercepts are where the graph crosses. If we're talking about a y-intercept, we would be talking about where does the graph cross a y-axis. And if we were talking about x-intercepts, we would be talking about where does the graph cross the x-intercept. Remember, if I was talking here about this x-intercept, this y-intercept this y-intercept is right here at 2. I didn't have to go left or right to get to that y-intercept, so my first point would be 0, and my y value would be 2. So with any y-intercept we have, in order to be on the y-axis, x will have to equal 0. This is a very important rule to remember. In order to have a y-intercept, x has to equal 0. Now let's think about this x-intercept over here. This x-intercept is at -2. We actually had to go to the left 2, which means our x is -2. And then we didn't have to go up or down, so our y is 0. No matter where our x-intercept is, because it's on the x-axis, that's always going to mean we don't have to go up or down. So our y is always going to equal 0. So whenever we're talking about an x-intercept, y is going to equal 0. Whenever we're talking about a y-intercept, x is going to equal 0. Let me say that again. I think I might have confused it. Whenever we're talking about an x-intercept, y is going to equal 0. Whenever I'm talking about a y-intercept, x is going to equal 0. So if we want to find this algebraically, all we would have to do for the x-intercept is set wherever our y is in the equation equal to 0 and solve for x. And then write the coordinates as whatever that x value is we just found, comma 0, because that would be representing that y equals 0. All right. If we're trying to find the y-intercept, then we would be setting x equal to 0. We would be solving for y, and then we would be writing it as 0, because that's the x that equals 0, comma whatever the y is that we found. So let's practice this. We do real quick. X-intercept means that y equals 0. So if I have 5, y, instead of y, I'm going to put 0, plus, I'm just rewriting the equation that was given to me in the beginning, 3x equals 30. Because I'm trying to find an x-intercept, I need to solve for x. 5 times 0 is 0, plus 3x equals 30. If you add or subtract 0, it's just going to stay the same, so we could just get rid of that. So it's going to be 3x equals 30. And to get rid of that 3, I just have to divide. 30 divided by 3 is 10. Meaning that my x-intercept is, the x value is 10, and the y value is 0. I could actually plot this point. Let's go plot 10, 0. 10, 0 would mean that we go to the right 10 and 0. Don't go up or down. And that is on the x-intercept, so we correctly found the x-intercept. That is on the x-axis, so we correctly found the x-intercept. Now let's find our y-intercept. To find the y-intercept, we're going to set x equal to 0. Let's write out our equation. 5y plus 3, instead of x we're going to put 0, equals 30. So then we get 5y plus 0 equals 30. We could just get rid of that 0, so then we're going to have 5y equals 30. Divide by 5, we get y equals 6. So my x is 0 and my y is 6. Which means don't go left or right, just go up 6. Now, technically with these 2 points, you could connect them, and you can draw arrows, and you can label it that this is the 5y plus 3x equals 30 equation, but I don't really like this method because I don't see a lot of extra points. To make sure I'm accurate, there's another way I can find actual points. We'll learn about that in a second. Let's just, you do this one, try it real quick on your own, find the x and find the y-intercept. So to find the x-intercept, we're going to make y equal to 0, and I'm going to have 3x minus 5 instead of y, I'm going to put 0, equals 15. So then I'll have 3x minus 0 equals 15. I can just get rid of that 0, so I'll have 3x equals 15. Divide by 3, I get x equals 5. And now as a point, x equals 5 and y equals 0. So we could plot that. 5 means I go to the right 5 and I don't go up or down. And that's on the x-axis, so that looks good. Now for the y-intercept, that would mean that x is going to equal 0. So write my equation, 3, 0 instead of x minus 5y equals 15. 3 times 0 is just 0, minus 5y equals 15. We could just get rid of that 0. So then we'll have negative 5y equals 15. Divide by negative 5, divide by negative 5, y equals negative 3. My x is 0, so my first number is 0, and my y is negative 3, meaning that I go down 3. And we could technically just connect these points, put our arrows, and label it as 3x minus 5y equals 15. But I want to see more accurate points and know what points I'm talking about. So if I do not want to graph this by hand, if I do not want to find my slope and my y-intercept, I can use our handy-dandy calculator. So let's just review the types of slope real quick. I just want to make sure we got this straight in our head. If we have a line that's increasing when we look at it from left to right, we would call that a positive slope. If I have a line that is decreasing from left to right, I would call that a negative slope. So that means that when you go to slope these, draw these equations, make sure that if you wrote down that the m is positive, your line looks like it's going up. If you wrote down that the m is negative, make sure your line looks like it's going down. Now, if you have a horizontal line that's not increasing from right to left, that is considered a 0 slope. And if you have a vertical line, a line that does not move left or right, that is called an undefined slope. Remember, 0 slopes have the equation of y equals, and undefined slopes have equations of x equals. All right, let's try this now. What do you need to graph a linear equation? First and most important thing is you need to make sure that your equation is y equals mx plus b. This is what we learned how to do in the last lesson where we rearrange the equations. Now our first option is we could then use the m and the b to graph it by hand. Or our second option is to make a table of values, which we can do using our graphing calculator, and then we can plot those points. So let's see how we're going to do that. How are we going to get the table of values? The directions right here are the directions from the calculators that we have at school. This calculator I'll be using here on the iPad is a little bit different, so just make sure you know how to do it on our school calculator. You would click the home button, click the blue graph button, type in the equation, make sure that it's in y equals, click enter, then you'll click Control T, and then you'll have your table of values. Alright, so those are the steps that we are going to use to find a table of values for a function. Now we are going to get ready to actually graph a function. So, if we have y minus x equals negative 1, we are not able to graph this. We are only able to graph something that is in the form of y equals mx plus b. So we need the only thing on the left side to be y. But here on my left side, I have y minus x. So using what we learned in the rearranging lesson, we are going to have to rearrange this equation. This is a nice one because The only thing that is on the same side as the left side is the minus x. So we have to bring the minus x to the right side. We have to think, what is the opposite of minusing x? It would be to add x. Add x. So now, that gives us y equals. We cannot actually do -1 plus x because they are not like terms. Now, you could write -1 plus x. That's not wrong. But instead, we write x minus 1 because that gives us the form of mx plus b. So, I'm going to go to my graph feature, and I'm going to type in x minus 1, enter. I could look at a picture of what the graph would be, but I don't want a picture of it. I want the table. So I'm going to go to table, and you want some negative numbers and some positive numbers. So maybe we'll do like -2, -3. Then we could do -1, -2. We then have 0, -1, 1, 0, and we could have 2, 1. You could have used any numbers that were in between -10 and 10, as that is how big our graph goes. So you could have also used -4, -6. I just chose to choose some numbers that were negative. I like 0, and some numbers that are positive. All right, let's review how we graph. To graph coordinates, when you are graphing your x value, that number tells you to go left or right. Left if it's negative, right if it's positive. Then you use the y number to go down if it's negative or up if it's positive. So let's go over this. -2 means go to the left 2. -3 means go down 3. Good. Then -3. The -2, -3, we go to the left 2, down 3. Good. So that's that point. Now let's look at the next point. -1, -2. We go to the left 1, and then we go down 2. And you should start to see that it's going to form a pattern. 0, -1. 0 is our x value, which means don't go left or right. The only thing that we have to do is go down 1. Then 1, 0. 1 is our x value, which means go right 1, but don't go up or down. Just stay on the x-axis. Meaning that would be our x-intercept. And then 2, 1, that means go to the right 2, up 1, and put a point. And now we can connect all these points. Use a ruler. Put arrows. We have to put arrows because this is a continuous graph. And then this is the graph of, we could write the original one they gave us since we know that's correct. Y minus x equals -1. That's the graph of y minus x equals -1. All right, that is correct. But I just want to show you how this is the same thing that we were learning in the previous lesson, where we were learning how to graph using slope and y-intercept. So let's look at this. Remember, we had the equation y minus x equals -1, which we converted into y equals x minus 1. Those are both equivalent equations, just different forms of them. So let's go over what the y-intercept is. The y-intercept is the number in front of x, which here, it's an invisible number, it's 1. What does that 1 mean? That 1, we like to make it into a fraction, is 1 over 1. Oh, no, the slope is the one we like to make into the fraction. Y-intercept you could just keep as 1. So y-intercept tells you to go up, or it tells you to go down. It's actually a -1. The y-intercept is a -1. The y-intercept is the one that doesn't have an x, which here the number that doesn't have an x is -1. So there, -1. So how do we start? Since it's -1, that means we go down 1. Y-intercept tells us to go down 1. And here we can see we did do that. Right here, we went down 1. This is our y-intercept. Now what I was saying before is our slope. The slope is the number in front of x. And here, the number in front of x is 1. And we like to make slope a fraction. So that would be 1 over 1. And now, how do we move slope? The top number is positive, so that means we go up. The bottom number is also positive, so that means we go to the right, because rise over run. So here, look, to get to that yellow point, we went up 1 over 1. To get to the next point, we went up 1 over 1. And once we didn't want to go up and over anymore, we could also go down and to the left. And look, we did do that. We went down 1 to the left 1. We went down 1 to the left 1. So you guys are going to get to choose, do you want to graph using the slope and the y-intercept, or would you rather do it using the table? But you're going to end up getting the same answer either way. This is a linear equation. That's when it's in the form of y equals mx plus b. That's when we are allowed to use the slope and y-intercept. Later on in algebra, when we learn about like absolute value and quadratics, we are no longer going to be able to graph using the slope and y-intercept, so we will need to know how to do the table way, which is why we are teaching that to you now. All right, let's look at this next question. Create a table of values and graph the following function. All right, this function is not in y equals mx plus b form, so we have to get it in the correct form. Here, I do see that the only thing on the left side is 3y, but I needed to only say y, so let's get rid of the 3. To get rid of the 3, we are going to divide all the numbers on the left and the right side by 3. That will help us on the left side get rid of 3, so we will be left with y equals 2 over 3x, and then negative 12 divided by 3 is negative 4. That is now in the form y equals mx plus b form. If we want to just use the calculator, we can go to our graphing function and we can type this in. And remember, we could look at the picture, but we really need it to be a table. So for the table, I like to get numbers that aren't decimals. I don't really want to work with decimals. Here, if I went up to negative 9, that's negative 9, negative 10. I don't really want to graph that point because that would be all the way like kind of at the end of my graph. Let me see if there's another one. Negative 6, negative 8, that looks good to me. Let's see what else is not a fraction. Negative 3, negative 6. Then 0, negative 4. 3, negative 2. And lastly, 6, 0. All right, so let's go over graphing these again. To graph negative 6, negative 8, you go to the left 6 and you go down 8. Oh, right here. I went down one too many. My bad. Negative 6, negative 8. All right. Now, negative 3, negative 2. We go to the left 3, and we go negative 3, negative 6. We go to the left 3, and we go down 6. 1, 2, 3, 4, 5, 6. Good. Now, 0, negative 4. You do not go left or right. You just go down 4. Then 3, negative 2. You go to the right 3, and you go down 2. And now lastly, 6, 0. 6, 0. We don't go left or right. We just go to the right 6, but we don't go up or down. Good. And we see that they did form a general pattern. And we can connect the points. We can put arrows on both sides. And I like to label it with the original equation that I was given, which was 3y equals 2x minus 12, but we were able to convert it to y equals 2 over 3x minus 4. Alrighty. Now, I want to show you guys again that whether you graph it using a table of values or using the slope and y-intercept, you will get the same answer. So let's look at this. First, let's think about our y-intercept. Your y-intercept is the number that doesn't have an x. So, the constant. Here it is negative 4. Y-intercept means you either go up or down. So to go to negative 4, we would start by going down 4. And I see that right here. This is my y-intercept. I went down 4. Okay. Now I got to think about the slope, the m value. That is the number, could be a fraction, in front of x, which is 2 over 3 in this problem. And how do we move over 2 over 3? Well, the top number tells us to rise. If we're rising 2, we're going up 2. If I'm running 3, I'm going to the right 3. And let's make sure this makes sense in the picture we graphed. We did go up 2, and we did go to the right 3. Good. Let's look again. We did go up 2. We did go to the right 3. We did go up 2. We did go to the right 3. Now, we could also go in the opposite direction. Instead of going up 2, we could go down 2. Instead of going to the right 3, we could go to the left 3. And let's see that here. Down 2, left 3. Down 2, left 3. And we do end up with that picture. Good. All right, and let's go graph another one after this. All right, let's look at this one. Create a table of values and graph for the following function. Again, this is not in y equals mx plus b form, so let's spend some time doing that right now. All right, I need to get this 3y so it is the only thing on the left side. So first I want to bring this negative 12x over. To do that, the opposite of subtracting 12x would be to add 12x. And then I also want to bring the 6 over. Instead of adding 6, I would subtract 6. So that would leave me with negative 3y equals, put the x first, 12x minus 6. And now, let's get rid of that negative 3. That negative 3 is being multiplied by y, so to get rid of it, we would divide by negative 3. So we would have y equals 12 divided by negative 3 is negative 4x, and negative 3 divided by negative 6 divided by negative 3 is positive 2. And this is the new equation that we will type into our calculator to graph. So let's type that in now. Negative 4x plus 2, enter. And then let's look at the table. Let's get some negative and some positive numbers. We could do negative 2, 10. In order to graph that, we would go to the left 2 and all the way up to 10. Then negative 1, 6. You go to the left 1 and you go up to 6. 0, 2. Don't go left or right, just go up 2. 1, negative 2. We go to the right 1 and down 2. And then 2, negative 6. We go to the right 2 and we go down 6. Beautiful. And now we connect these points. We put arrows. And I'm going to write the original equation name that I was given. Good. That is a great graph, but we just want to double check that everything about that graph is good. So let's go just check with our slope and y-intercept. Y-intercept. Your y-intercept is your constant, your number that doesn't have an x, which here is 2. Y-intercept, you will either go up or down. So here we would go up 2 since it is positive. And I see that graphed right here. That's my y-intercept or your b value. And now let's talk about your slope. Your slope is your number in front of x, which here that is negative 4. We always want to make that coefficient, the slope, into a fraction. So we're going to make it negative 4 over 1. Remember with slope, your top number tells you to rise. If you're rising negative 4, that means you're going down 4. And if you're running 1, that means you're going to the right 1. And let's look at it now. We're going down 4 to the right 1. I end up at that point. We go down 4, right 1. I end up at that point. And now if I want to do the opposite, I could go up 4, but to the left 1. So up 4 to the left 1. And then I could go up 4 and to the left 1. And look, I made my nice graph. Now we are going to move on to graphing equations that say x equals and y equals. This next one, y equals -4. Let's see this. Y equals -4. Let me go to my graph. Y equals -4. Okay. And let's go and make a table. Second table. Ooh, for no matter what number I have, my y is always going to be -4, -4, -4, -4, -4. So that means no matter if I want to do -2, -4, that means I'm going to go to the left 2 and down 4. -1 means go to the left 1 and down 4 right there. 0, don't go left or right, just go down 4. 1, go to the right 1, down 4. 2, go to the right 2, down 4. When I connect those points, it's just going to look like a horizontal line. Because any equation that is y equals a number where there's no x, you are just going to plot the point at the y-intercept. Here the y-intercept is -4, and you're just going to draw a horizontal line through it. And let's try this next one. X equals 5. Remember, when x equals 5, that means for no matter what number, x is always going to equal 5, and you can make up any numbers for your y's. And you're going to go 5, 1 means go to the right 5, go up 1. 5, 2 means go to the right 5, up 2. Up 3, up 4, up 5. And now connect all these points, put your arrows, and put x equals 5. So whenever you have x equals a number where there's no y's, it's going to be a vertical line. And that is how we graph equations when we are given a table of values. Well, sometimes we have to find the table of values. Alrighty. Now we should be pros at graphing linear functions. They don't even need to be in slope-intercept form because we now know how to rewrite them.